Everyone, this is John Wen. Today is December 9th, 2020. In today's video, I'm going to go through the research updates since the past week. In the past week, I was working on preparing some slides to show the design as well as the interface of the deep learning workflow that may happen in the data view system. Here is one sample deep learning workflow. As you can see, we can have different tasks to add different layers into the model we want. Basically, the data flow through these tasks are hash map. So finally, by incrementally increase the task or adding the layers by the tasks, we're going to get a final hash map as input to the start training task as well as input data. And by training and testing, we can get a prediction score as well as we can save the model into a file. And by reconstructing the model by this reconstruct model task, as well as we can input the new data and we can get the prediction score. So this part can be included as a part of large scientific workflow because maybe we do not only use once for any good model. We want to reuse that as long as we need. So we always need to reconstruct that model by the different workflow or by the different tasks. And for this part, we may be able to implement with reinforced learning. So here I mark the model can be saved as a file. So in the past week, I also did testing, which is I refined the code a little bit, and I use some new constructor or data structure to save the data, as well as I try to output the weights after the final result, after the final training. So here is a code I was trying to save or trying to print out the model. So as you can see here, here is a code I'm trying to, So here is a code I was trying to retrieve the layers after the training, and most importantly, I have to copy the data from the device to the host. So if we are going to run this deep learning workflow and I make the epoch really short, so this will be easily finished. So as you can see, I was able to get the weight matrix for the linear layer, which is 2 rows and 30 columns. And here is a weight matrix, as well as I can get the bias matrix, which is 30 rows and 1 column. And here is a final result. So basically, after we get this data, maybe you can save into some file or save into some Excel, and we are able to reconstruct this model by the data such as the weight as well as the bias. This is for the linear layer. And let's go back to the slides. As you can see, I mentioned that maybe this part we're able to use reinforcement learning. And here is one example. Maybe I think we can have some context, for example, like the row sign detection or row detection. So basically they are quite similar. I was trying to find some good data set on the Kaggle, and here is one example on the row sign detection. So basically here are some sample data. Maybe we have to do some bounding box to extract the data, and then we are going to learn these pictures by our deep learning workflow, and then we can output the final prediction model. So if we take a look at this graph, maybe we are able to do things like this. And we can have maybe 3 models initially. There are 3 different kind of CNN workflow added with different layers. And after we do the training and testing, we are going to get some model with prediction score, and we can get the best one, right? And for them, we can do the crossover as well as mutation. So this is something similar to the cultural algorithm or the reinforcement learning, such as a small particle algorithm or some other things. So we are trying to move towards the best model. And then after we get the mutation and crossover, we will get something new. For example, like workflow 4, 5, 6. And we can start from them by doing the reinforcement learning. We are going to train and testing this model again. And finally, we are going to get the model 4, 5, 6, as well as we also will get a best model among these 6, I would say. So again, this will repeat as long as how many times we want, maybe 5 epochs or 10 epochs or thousands epochs. So finally, we will get a best model. As before, we are able to reconstruct the model with this task and then input with new data. So we are able to reuse this model as long as we need and whenever we need. So that is the idea. And thirdly, I was thinking about maybe as in before Trilling and Andrew, they were working on the reference architecture of the data view system. Maybe we're able to do a similar thing on the deep learning workflow as well. So I was trying to think about these aspects as well. What I can think about right now is maybe the architecture will be simple, the challenge will be straightforward, but maybe what I need to do is think about the scheduling or provisioning strategy. So I was trying to research a little bit and I found that maybe this is interesting. The multi-GPU processing, so which is able to give us different performance if we have multi-GPU in one computer and we can combine maybe one, two of them or three of them as a whole as a maybe higher performance cluster or high performance GPU, so we're able to train more tough tasks or heavy load tasks. So that is the idea. But for others, if we don't combine them, they still can be trained with single deep learning workflow. So for example, like here, if we have 3 GPUs, we're able to combine 2 of them. Maybe we train on workflow 1 because this one might be heavy load, and then we still have 1 available. Then we can train the second workflow individually, so they will not interfere with each other. So we are able to get the result maybe at a roughly similar time by the end of these 2 workflows, because we are running them on different hardware, only on one computer. So that is the idea. But I'm still thinking about this direction, and maybe I will get better understanding. But this is something I hope to share at this moment with you guys. So I think that's pretty much for the updates from the past week. So I hope you guys enjoy this video. Until next time, happy coding.